the time domain specifications. Right, through the time domain specifications, what are the important things we can learn? Right, so that is the concept behind that. So if you are taking any type of response, right, there will be in the response you can find out these time domain specifications. So say the delay time, rise time, maximum overshoot, then finally the settling time, right? So how we can identify? Let us solve some of the problems from the given data, right? Then we can move to the next topic. I hope you know the importance of this time domain specification and the analysis behind that, right? So I'll try to share my screen so that it will be much easier to understand. Well, listen, hereafter I'm using this Microsoft whiteboard, so I hope it will be giving more insights when compared to the previous system while we are writing in the presentations, PowerPoint presentations. So we are going to take on open loop transfer function, and for that open loop transfer function we are taking a feedback also, and we are going to find the domain specifications. All right. So the time domain specifications, some problems we are going to see. So in a unity feedback system, just I'm writing the problem. In a unity feedback system, so the open loop transfer function GFS is given. So I'm giving the transfer function GFS, that is equal to 10 divided by S into S plus 2, right? So the GFS value is given. Let us see what are the other values in the given data, so that we can find out the domain specifications. So that's all they given, and find the time find the time domain specifications. Right, listen, so the unity feedback system, that means h of s is given, right? Since it is a unity feedback system, therefore we can write the value of h of s. So that is equal to unity, that is equal to 1. And the GFS value is given, and now they ask us to find the time domain specifications. You know that the time domain specification means it will start from rise time, uh, delay time, maximum overshoot, peak time, settling time, etc. All right, we are going to find all those values, right? So let us write the closed loop transfer function for the system given. So what I'm doing means the closed loop transfer function. Closed loop transfer function, which implies so how to write the closed loop transfer function? In generalized thing, we can write CFS divided by RFS, right? The Laplace transform of output to the Laplace transform of input, that is equal to the generalized feedback system. Say it will be like one GFS is there, right? And the GFS value is given. So like that, and here what they given, feedback is given. So here it is. So and the feedback is unity. So if the system is given like this, you can say here RFS is the input and CFS is the output. So if the system is given CFS by RFS, means how we can write GFS divided by 1 plus GFS into HFS. So I hope this thing you know that previously, right? It is not new to you.
Sir, for an unity feedback, the HFS won't come. No.
Yeah, HFS will be 1, right? HFS won't come. Therefore, we are substituting HFS equal to 1. And therefore, we can write GFS is equal, CFS by RFS is equal to 1 plus GFS, right? HFS is unity. Now, what I am doing means I am going to substitute the value of a GFS since it is given in the problem. Here you can see that GFS equal to 10 divided by S into S plus 2. Therefore, here I am substituting 10 divided by S into S plus 2, right? So divided by the whole divided by 1 plus 10 into 10 divided by S into S plus 2, right? Simply substituted the GFS right here. Therefore, what it will come, that is equal to so 10 divided by S into S plus 2, that is in the numerator as it is. Denominator, if I am taking LCM, therefore S into S plus 2 plus 10 divided by S into S plus 2. I hope you can understand. If you are multiplying here, then you can take common. Now you can cancel this one and this one, right? Therefore, that is equal to 10 divided by S into S plus 2 plus 10, right? So again you can simplify, you can multiply S inside, therefore we can write C of S divided by R of S, that is equal to 10 divided by S square. If you are multiplying here, S square plus 2S plus 10, right? And now we are going to compare with the generalized form, right? For the time domain specification, we need to compare with the generalized form. So the generalized generalized second order the generalized second order system, which implies we can write CFS divided by RFS, that is equal to I think I given already, that is omega n square divided by E square plus 2 del omega ns plus omega n square. So I hope this thing you know that it is nothing new. So already we derived all those things, and now what we are going to do means just we are going to equate these two equations. Right, let us see. This is also CFS by RFS. I can take it as 1, and this is also CFS by RFS. I can take it as 2. Now you can equate 1 and 2, which implies how we can write. Here you can see the left hand side CFS by RFS, here also
Sir,
CFS by RFS. Yes.
sir, how did this generalized second order system appear, sir? Did they give this in the question?
No, they never give. See, it was given like this is the second order system. That means you from the problem itself, we came to know that it will be like a second order system, right? So if it is a second order system, you need to equate with the second order equations. These second order equations, how it came, that we derived earlier, right? The generalized system. I hope some classes before
Sir, after solving
we
this T of S, I mean this transfer function, we will get to know whether the system is in first order or second order.
Yes.
Okay.
If it is a second order system, we have to equate with the second order equation. All right. So I hope you understood. So now you can see that we can equate both the equation. If the left hand sides are equal, therefore the right hand side should be equal. Therefore, from that we can write that is omega n square, that is equal to 10. Right. So from that we can write that is omega n is equal to, that is a root of 10, right? Therefore you will get the answer, the root of 10. So if you are having calculators, tell me what will be the root of 10 value. That is
3.1.
3.162, am I right? So the omega n value is equal to 3.162.
3.162.
Very good. So this value we got it, and similarly we can equate other things. 2s is given, and here 2 del omega n into s is given. Therefore we can write 2 del omega n, that is the coefficient of s, and here the coefficient of s is equal to 2, right? Therefore from this we can find the del value, that is a damping ratio, because omega n also we know that. Therefore this 2 and 2 will cancel each other, right? Otherwise this 2 will go there. So I can write omega, not omega n, we need del, right? Del is equal to 2 divided by, I am taking this 2 into omega n in the denominator this side, that is 2 into omega n, right? That is equal to 2 and 2 will cancel each other. Del is equal to 1 divided by, but the value of omega n is 3.162. Can you tell me now what is a del value? Del is equal to 1 divided by 3.162, you will get point,
0.31.
yeah, 0.316. Very good. So the answer is 0.316. Very good. So we'll take up to this one. So here you can see that the two values we got it, that is one is omega n, that we need, another one is del, because in the time domain specifications we need these two values, that is very important for calculations. Right now we are going to find one by one the rise time, peak time, etc. Since you know the value of del and the value of omega n, the other values, it will be very easy to find out. Because we derived what actually this peak time, what actually this rise time, etc. Alright. So first of all, I am going to find the peak time. That will be easiest thing. Therefore we can write peak time, because they ask the time domain specifications. Therefore peak time, I am putting it as TP. So anybody remember we derived the TP, right? We are having that formula. So what is the formula for TP? That is equal to pi divided by omega d. That is the formula. Anybody remember this one? We derived in the previous session, right? Previous or before that session, I hope. Right? Pi divided by omega d, and we can find the value of omega d also. How we can find omega d? So there is a relation while we derived. We are having the relationship between omega, del omega n and omega d, right? While we are substituting that in the relation, we can get it. Are you able to remember the relationship between omega d and omega n? that is omega d is equal to omega n into root of 1 minus del square. Therefore we can find that thing, that is omega d is equal to omega n into root of 1 minus del square, right? Therefore if you are substituting, so we know that omega n value, right, omega n is 3.162. So here you can substitute 3.162, and the root of 1 minus del square is 0.316 square, right? So now if you are simplifying this one, you will get the answer. Please solve it and tell me what is the value of omega d. So once you know the value of omega d, immediately we can find the value of Tp. Can you tell me what is the value of omega d you are getting? Please put it in the calculator. That is the root of 1 minus del square divided by del. Omega d is equal to omega n into root of 1 minus del square. If you are substituting, I'll get the answer. So I hope you'll get the answer as 3. It's right. 3.0001 I am getting, so I am making it as 3. Omega d value, are you getting the same value? Please check.
2.16.
No, please do it correctly. That is 0.316 the whole square, right? Yeah, 0.316 the whole square. Then you substitute 1 minus that value into root. Then you take the root and multiply with 3.162. I hope you will get 3 is the value. So if you are substituting, please check again whether we are getting the values.
2.615 it's coming.
Others, can you check? I am getting 3.
Sorry, sir, I did not square, sir, that one. 316.
Check carefully, I think you will get 3. So once again I checked, so the value is 3 only. Now what I am doing means I am substituting the value here, that is Tp is equal to, that is pi divided by 3, right? You know that pi value is 3.141. You can substitute that value 3.14, and then you will get the value as 1.04, I think. That is, if you are substituting here 3.14 as the pi value and divided by 3, so we'll get the value.
Sir,
Yeah.
the value of omega d is 3.0066 it is coming, sir.
Yeah, you
Expecting
can
the decimal.
put it as 3. Yeah, you round it.
If we have, if we take that approximately also it will come, no, sir.
It
3.
will come. It will come. No issues. And now you substitute here, that is pi value also 3.14 divided by 3, so we'll get the value of peak time.
3 it came, sir.
Yeah, good. 1.047. So I hope you'll get the answers in seconds. Since listen, another important thing I want to tell you, to put the units here. See, since it is angular velocity, and here we can write it as radian per second. So here also radian and radian per seconds it will be. Then finally you will get in terms of seconds. Right? Therefore, you find out the value, that is Tp is equal to this one, that is 1.041 seconds.
Sir, sir, can we know this?
I think your voice is not clear. Can you ask again?
No, sir. Can you
Okay,
observe?
okay, good, good. So then we will find the rise time. So till now we is seen this peak time. Yes, then we are going to see the rise time, because they asked the time domain specification. We need to find all the rise time, and it is represented by t suffix tr. The rise time tr is equal to, anybody know the formula? We derived already. Pi minus theta divided by, oh my god, I hope this is the formula we are having already. So we need to find the value of theta also here. So from the right angle triangle of the derivation, we know that del and root of 1 minus del square are that both are right angle to each other. From that we can find the value of theta. So I am substituting the value of theta here. That is theta is equal to theta is equal to tan inverse of root of 1 minus del square divided by del. Therefore we can find the value of theta by using that. Well, listen, this I am not simply introduced. Actually, while we derived the derivation of the second order system, it was inside, right? If you are having in the note, please check it. You are having the similar type of root of 1 minus del square and del here, and now we are substituting that value, that is the root of 1 minus what is the del square value? The del square value is equal to, yes, 0.316 square. So I hope it will be easy, since you already calculated 0.316 square, right? All divided by del is 0.316. So now if you are taking the tan inverse, you will get the value of theta. So you tell me what is the value of theta? Now please put your calculators in the radian mode and calculate. While you are finding theta, please put your calculator in the radian mode. Why? Because we don't want theta in degrees, because all the values are in radian now. That's why I given radian per second. Therefore, while substituting a tan inverse, please put it in the radian mode. So I hope you will get 1.249 radian, right? Right, for you, that is equal to 1.249 radian, right? That is the value of theta. So all other values now you know that, right? We know the omega d value, you know the pi value, that is 3.14, and theta value. Now you substitute here, that is tr, is equal to pi value, that is 3.14, minus theta value 1.249, divided by the omega d value. Omega d value also we find out, that is 3, that is divided by 3, and you will get the rise time. And tell me what is the rise time you are getting. Just substitute in the calculator and tell me, you will get the rise time. So I got it, the rise time, that is equal to 0.63 seconds rise time. Please check whether you are getting the answer. That is, rise time is equal to 0.63 seconds. Now listen, the time domain specifications, we found out the peak time. Similarly, we found out the rise time. Please do it by your calculators. It will be much easier. If you want the delay time, easily you can find out, right, the 50 percentage of your rise time, right? So normally they won't expect, right? If you want, you can find it. That will be good. Also, we derived the formula for the percentage overshoot. That means next to the reference, that is how much it will be there, how much peak it is going. That we called it as the peak overshoot. So let us calculate the peak overshoot also next. So shall we move to the next one, that is peak overshoot. It is represented by M or MP, M suffix P, right? Because it is maximum, M stands for, and P stands for the peak, right? So both it will combine the peak overshoot. That is MP, it will be given like this, right? M suffix P. So I hope universally they accepted this term, peak overshoot. So if you're having the formula, you can write it. Previously we derived, that is peak overshoot, we can write it as M suffix P is equal to e power minus del pi divided by root of 1 plus del square, am I right? Or 1 minus del square, minus del pi divided by root of 1 minus del square. So this thing also we derived already. So you can substitute directly, you will get all the value, that is equal to e power of minus, where is the del value? Del value we got it, I think, right? Because we substituted already. Oh yeah, that is equal to 0.316. Here also we can substitute, minus, that is 0.316 multiplied by 3.14, the whole thing, that root of 1 minus 0.316 square. So while you are substituting, we'll get the value. Please tell me what is the value you are getting. Now listen here, it is simply substituting the values. So if you are able to substitute, you can get it. If you know the formula, you can get it. If the end semester examination is open book, means you can have all the formulas with you and directly you can substitute. Right? You know how to substitute, and you need to be very careful about the units, right? And then you will get the answers. You arrive the results very easily. So some common sensible values you can keep it in mind. Always your peak time will be more when compared to the rise time, right? And rise time will be more when compared to the delay time, right? If the rise time is 0.63, then delay time it will be 50%, right? So it will be 0.315 like that. Like that it will varies, so that you keep in mind, because you know the delay time will be the first, next rise time, next it will go to peak time, and finally it will settle. So depends on the time variations will be there. And this peak overshoot, it actually telling that is how much it will rise, right? The overshoot. So that we need. So have you got the answer? If you are able to substitute in the calculators, you'll get the answer. So check whether we are able to get to this one, 0.351, right? So sometimes they may noted this thing in terms of percentage. Therefore, the percentage of overshoot, that means that is 35.1 percentage you can write. So we find out the rise time, we find out the peak time, then overshoot. Then one more thing, the settling time we can find out. For settling time, we can take it as for 5% errors, 2% errors. That is up to us. Right, for 5% error, I am taking. Just I am giving the title as settling time. Settling time, it is given as t suffix s, and for 5% tolerance, it implies. If it is a 5% tolerance, how it will be? We will write how the settling time, that is Ts is equal to, Ts is equal to, are you able to remember? We written already. 5% tolerance, Ts is equal to 3 multiplied by T, and this is the time constant value. The time constant T is given by so I hope that also we derived, that is time constant T is equal to 1 divided by del omega n. So that is equal to 1 divided by del into omega en value. Del value is given here, that is 0.316 multiplied by, where is omega n value? Omega n value we found out already. omega n value is 3.16, 3.162, right? We can substitute that value 3.162 here. That is equal to 3.162. Therefore, 1 divided by this value, please tell me what you are getting.
954.49.
954, no more.
Uh,
So if an
one value is wrong.
0.316 into 3.162. I think here you will get 0.999 or 1.0007 like that you will get. So I hope you will
3
get
point
one. Check more. You will get one. T is equal to 1. Therefore, Ts is equal to 3 multiplied by T. That is T is equal to 1. Therefore, Ts is equal to 3 seconds. So please check carefully. I hope you will get the answers like that. So listen for the time domain specifications they asked in the question. Right, the four things we got it. I want to show you one by one. The first thing is the rise time, right? Peak time we calculated, right? So this is the one. So this is the one. They will check the answers like that. So this one it will be okay. And next we can see that rise time. Yes, this is okay. If you want the delay time, easily you can write T is equal to that is 0.5 percentage, that is 50 percentage of rise time, that is equal to 0.315, am I right? Seconds. So if you want delay time, that also we can put it. So this is over and rise time is over. So how many answers we find out? 1 2 3. Then yes. So this one, this maximum overshoot, this is also over, and finally the settling time we find out. Now listen, for everything if you are putting the right formula and the right substitutions, you'll get the answers. Right? I hope you understood. So if you are able to understood, we can move to the next unit from the coming class. Any doubts there? So similar type of the problems they can ask in the end semester examination. The base is one, you know about the derivations, right? If you know the derivations, you can easily get the solutions, means the end results, or you write the end results particularly with you, right? It will keep the understanding level more. Then directly you can apply these values in the formulas, you will get the answers. So that's all from my end about today's session. And if you are having any doubts, you can ask me.